In this exercise, you will learn about the thermocouple. Thermocouple converts the thermal energy into electrical energy. Thermocouple is a device which is used for measuring the temperature of a given substance. Principle of thermocouple is based on Seebeck effect. According to Seebeck effect, when the temperature at the junctions of two different metals differs, then an EMF is generated in a closed loop. This EMF causes an electric current to flow in the closed circuit. Thermocouple consists of two wires of different metals joined together within a loop. Let the two metals be named as M1 and M2. Assume that the metal M1 is copper and M2 is iron. Junction A is in contact with a body whose temperature is to be measured. This measured junction is usually called as hot junction. Let the temperature source at the junction A be a beaker filled with hot water. Junction B is in contact with a body whose temperature is known. This junction is always called as cold junction. Let the temperature source at the junction B be the beaker filled with cold water. Assume that the temperature at junction A is T1 and the temperature at junction B is T2. In this case, the temperature T1 is higher than T2. Hence, the electrons at the hot junction is highly energized than the electrons at the cold junction. The highly energized electrons from junction A move towards the junction B. The electrons flow from junction A to junction B is through copper metal because only one metal reacts for the unknown temperature T1. This movement of electrons creates holes at junction A, making it positively charged. The accumulation of charges at junction B makes it negatively charged. Since the junction A is positively charged, it attracts the electrons at the junction B towards it. Therefore, the return flow of electrons from junction B to junction A is through iron metal. The electrons at cold junction will not be as highly energized as the electrons at hot junction, hence they move slowly. The direction of current flow in the hot junction is from copper to iron. The direction of current flow from the cold junction is from iron to copper. Charge neutrality is maintained at both the junctions A and B. In order to find the unknown temperature at junction A, the current flowing through the thermocouple should be measured. Now, the loop can be opened at any point inside it. An EMF appears across the open circuit points. This voltage is measured by connecting a voltmeter across the open circuit. The measured voltage V is proportional to the temperature difference. The formula for calculating the unknown temperature T1 is given by V equal to S into T1 minus T2. Here, S equal to S1 minus S2, where S is the overall Seebeck coefficient, S1 is the Seebeck coefficient of metal M1, and S2 is the Seebeck coefficient of metal M2. The generated EMF depends on the type of the metals used and the temperature difference between the two nodes. Is classified into different types based on the types of the metals. Types of thermocouple and the temperature range are shown in the chart. The sources at the two junctions can also be interchanged. hot source can be at cold junction and cold source can be at hot junction. In this case, the polarity of the current flow will be reversed in the loop.